This video is the second part of our quadratic formula video for Math 20-2. It shows two more important examples for you to follow and understand as it relates to the quadratic formula. So again, the quadratic formula is just this big formula that's always provided to you, and it's another way to find our x-intercepts, our zeros, solutions, our roots to any kind of quadratic or parabola if you don't want to factor, or if the quadratic is not factorable. So that's when we use this. So we're going to jump right into our examples, and this is the quadratic over here, 2x squared minus 7x plus 5 that we're going to look at. From here, and in the previous videos, we know that a is 2, b is negative 7, and c is a positive 5. So those are our three variables that we have to use inside the quadratic formula itself. So let's just get into that right now. So we're looking x equals, we're going to substitute the values in. It says negative b, so that's negative 7, because b was a negative 7, plus or minus b squared minus 4ac, so b squared negative 7 squared, remembering that those brackets are important, minus 4 times a, which is 2, and times c, which is 5. That's the top of this quadratic formula, or the numerator, and the denominator simply 2 times 2. So we can just do our calculations and start to simplify. So up front, negative 7, that's a positive 7, plus or minus, now we look at the radicand underneath this radical sign, negative 7 all squared is a positive 49, and then we just multiply these three values. So we have negative 4 times 2, that's negative 8, and then negative 8 times 5 is negative 40, and the denominator 2 times 2, simply 4. So now it's a matter of just cleaning up again. So we got the 7 out front, plus or minus 49 minus 40, well that's 9, all over 4. And you can see now that the square root of 9 is actually a number that we can consider. So we're saying x is 7 plus or minus, now the square root of 9 is just 3, all over 4. So remembering back to our other videos, we know that this plus or minus tells us something about our next calculation. We say, well, x can be 7 minus 3 over 4, or x could be 7 plus 3 over 4. Now you can see we don't have to deal with radicals at all because we had a perfect square there. This just turns out to be 7 minus 3 is 4 over 4. So one x-intercept is at 1. The other one, x equals 10 over 4. Also, this other x-intercept is at 5 over 2. So this is a quadratic that probably could have been solved using factoring, but our quadratic formula still comes up with our two x-intercepts, which is pretty important. So the last type of example we need to consider here for the quadratic formula is one like this. The quadratic itself might just look the same as everything else, but going through with this quadratic formula, you're going to realize that something different is going to happen than all the other examples we've done in these two videos so far. So here's that quadratic formula. And we can go back to the equation itself, and we could say, okay, I know x is 3, I know b is positive 4, and I know c is positive 5. I'm going to use those values inside the quadratic formula. So x equals, well, negative b, well, negative 4, plus or minus, here comes the radicand, so that's 4 squared, minus 4 times 3 times 5, all over 2 times 3. So the substitution by now should be easy. Now x equals, we're going to deal with the numerator first. So a negative and a 4 just gets me negative 4. Plus or minus, now we look at the radicand, 4 squared, that's 16. And we look at this part, negative 4 times 3, that's negative 12, times 5, that's negative 60. All over 6. Now we try to do the simple calculation inside the radical sign, or the radicand itself. So negative 4 plus or minus square root of, well, 16 minus 60 is negative 44 all over 6. Now a red flag should be going up right now saying, whoa, back in junior high in the beginning of our radicals unit this year, if the radicand is negative when we're doing a square root, this just cannot happen. We cannot calculate that. So this tells us something very important about this parabola or this quadratic. Because the radicand is negative and we can't take the square root of a negative number, this means this quadratic simply has no solutions. There are no x-intercepts. So in terms of the graph, if we were to look at this visually, this thing should not be crossing our x-axis anywhere. So we're going to look at it on our graphing calculators. I'm going to put it in for you to take a look. So I'm going to say 3x squared plus 4x plus 5. So if I was to graph this, when I hit graph, we should see a parabola. First off, we know it's going to open up because of positive leading coefficient. And because we just did the quadratic formula and we realized that we can't calculate it, this should not be crossing our x-axis anywhere. So when we hit graph, there's our parabola. There are no x-intercepts. So basically, this thing will have no solutions. Or if we look way back to the original question, this question itself, there are no values of x that I could put in here that would make this equation equal to 0. So there's a lot of different ways we can use the quadratic formula, a lot of things it can tell us. Mostly it's telling us our x-intercepts, but as this example shows us, it also tells us when there are no solutions to the quadratic at all.